my own message. Time up. So I don't know why people are saying we're just submitting. Um Ada, is Ada, are you there?
Okay, yes, yes, sir.
So don't forget my attendance for the week. And I've not
Yes,
you
sir.
guys have not submit your assignment to. I give an assignment. 2 assignments per se. None have been submitted. I don't know why, but it's before the week runs out, I want my assignment to be submitted so I can teach the class on time. Okay. That being said, let's start the class proper. So we are continuing from where we stopped when we stopped uh yesterday, and that was on conceptual models. So I'll be sharing my screen now. I hope you can see my screen.
Yes, sir.
So I believe you remember when we were talking about data modeling, the steps involved in data modeling. The first step, which is actually data modeling itself, database modeling, database design and modeling. The first step in database design and modeling is actually the first step, which is actually called data modeling. Now, after data modeling, once has been concluded, you have moved to the second step, which involves using concepts in expressing your data models. Third step involves, which is also a two-in-one step, which will involve logical design and physical design. Logical design involve us tailoring what we have previous other involve tailoring what we have to suit tailoring what we have to suit a particular DBMS configuration. What the physical actually means the physical implementation of such a database. Now, I remember that we end on what you call it on data modeling itself in proper, where we are actually enter the world of data modeling itself. On data modeling, we talk about what is data modeling is all about. We talk about the degree of abstraction and the rest of it, where we actually end up with data conceptual models. Now, what leads to conceptual model? What leads to conceptual model was the fact that we are still in the first stage of what? Database design and modeling, which avails us the ability to first model. And as we are modeling our data, we have to understand rather the nitty-gritty of conceptualization. Now, I know you guys have ideas. I believe everybody has an idea on how to succeed today. Yes or no?
I didn't know how to work.
I can't hear you.
We didn't hear your question.
I believe that everybody has a factual concept of how it's going to use today. Like you have a paper, some people may have a paper, some people may have a timetable, some people may have an idea of okay, today, this is how I'm going to spend my day. I believe everybody has that concept.
Yes, sir.
I can't hear you.
Yes, sir.
Yes, Abi?
Yes, sir. Yes, sir.
Okay. So what you have is what is called a conceptual design. Like myself, I have a design already that today this I'm going to do today, of which I can call those things conceptual design. In my conceptual design, I'm factoring the items I need, the relationship between the items I'm going to do today, and the constraints that will be set for each of the actions or items I'm going to be attacking today. So probability can be that I achieve them all my to-do list. I actually tick them today, or probably I failed to tick them today. But the process of me designing my conceptual way of living today is what we call, all those things is what we call conceptual models. Is that understood?
Yes, sir.
Okay. So now, doing our conceptual modeling, data modeling, we need to understand that there is a degree of abstraction. What do I mean by degree of abstraction? Things that we have to ignore when we set priorities, those things that are to come into the picture and those that we can actually ignore. One of which is the external model. External models talk about the users, the end users. So you are all surveyors in the making. Surveyor in the making, you are like a data gatherer. You're also a data gatherer, you're also a data presenter. Also a data presenter, you are not also an expert witness when it comes to court or legal proceedings. Now, that being said, that means that if you have to gather data, there's some data that you have to ignore. There's some data that you have to actually set priority on. So there's always what you call a degree of abstraction, meaning that you focus on those things that are vital for the user. So in doing that, you need to understand the external model that involve the user's view of the database, what the user is all about, who are the user, and what they need to be aware of. And do you want to show them everything? That's one. Two, you need to come up with your own conceptual model. In your conceptual model, you are actually trying to understand the structure of your entire database, the content, the relationship, the constraints, the security and integrity information, the semantic information. Especially, you have to understand details about your database. Now, in today, we are going to be furthering on the concept of data modeling. Now, going further, after you have done your what they call you have come up with your own conceptual model, then the next thing or the next team of interest is what we call the internal models. Now, remember, your first step was looking at the concept. Your second step is now looking at the internals. What are the things that your specified DBMS will be requiring you to actually set? So in internal models, you are looking at a database that consider a system of file or fixed size records. You know, in your laptop or on your system, every document are saved as a record, yes or no?
Yes, sir.
Yes, sir. That is to say, if you have a document, you have to create a folder for your document. If your document is also a folder, all your file systems in your document, in your computer, they are saved in folders, in directories. They usually call a file system or record storage system. So definitely for internal models, you'll be considering how a database can be a collection of fixed size records. You are looking at a physical level or file structure system. You are looking at how your software or DBMS will actually represent your database. Don't forget that your database is for the user at the end of the day. It's not for you, it's for the user. However, your system on the other hand, your computer on the other hand, your machine on the other hand, device on the other hand, will not actually consider the user. You, the designer, answer. It's you, the designer, that will actually consider how you, the designer, I say you the design database, you that will consider how your computer will be storing your data. Then, furthermore, what we're trying to actually achieve with the internal models is that we're using our internal models to match our conceptual models with the computer-oriented implementation models. So we can actually conclude that our entire models refers to computer-oriented implementation models. How you want to model your data, such that your computer or your specified system or software, you understood that yes, so this is the way you want to record or structure your database within that same software environment. Good. Finally, if you have actually been able to actually implement or able to actually come down to your software, you know how to use as access, you know the secret about access, you know how to save in access, you know the file type and file records in access, and you are able to actually design, okay, how the record will be saved in the access. Now, we now go back to the final one, which is the physical implementation, and the physical database design. In this step, we use what we call the physical models. The physical model is the lowest level of abstraction, meaning that we are trying to actually implement it now. We are looking at the hardware. Yeah, we are considering the hardware that will be required for us to represent our words, our database. Imagine you having a hard disk. That hard disk is actually a physical model or a physical representation of your database. If you store all your files using let me say using Microsoft Access or using Oracle, and everything is saved in a flash drive. That flash drive that is keeping your DBMS is actually a physical representation of your database. Meaning that all your database is stored within a flash drive that can be accessible when connected to a DBMS of your choice that you have designed with. So in a physical model, is the lowest level of abstraction, meaning that in this model, you hardly ignore any.
So I was like, maybe you can meet up and talk.
I can't hear you. Are we talking to me? Is there any problem?
I'm around Aluta Market.
Man, are you talking to me or talking to another person?
Right now.
Hello? Someone interrupting the classroom.
606 hash.
Can I go on? Hello, class, can I go on? Hello?
Yes, sir. You can go on, sir.
Okay. Now, physical models, as I've said, this with idea of data storage. The data storage, maybe the size of the database you're looking at. Imagine before, Google was using a localized server where all the data are stored within a centralized server where they have a data warehouse where they keep all the hard disks, all the servers, all these computers that store your data. They all of a sudden they find that they cannot manage all your data within a location. They have to now spread it around such that they have a deep sea facilities, they have a sky-based facility, they have a data-based facilities, they have so many facilities that can actually store your data. So when it comes to physical models, we are looking at data storage capacity of your physical structure or physical hardware that you want to use. The performance, the other performance of the computer. Okay, how fast do you want us to be able to access your database? How fast do you want it to be processing? And the rest. We are looking at data encryption. We are looking at how safe. Okay, imagine everybody's using WhatsApp. Imagine if someone be able to hack your system, will you be able to have access to the database? Imagine someone steal your hard drive in which you save all your data. Can that person just be able to access it from anywhere, or can just input in the system and to just pop up and reveal the content of database? You're looking at the operating system, and actually you're looking at the physical realities involved in designing your database, involved manipulation of your database. So when it comes to physical realities, we are using what you call physical models. We are considering what's called physical models. In this kind of model, you do a list, you do a list data abstractions, meaning that you hardly leave out informations like before. when you are looking at the students, you don't want to care about the color of the students. But when you are looking at the practical implementation, you want to care about the color, the physical, the color of your hard disk, the storage, where your hard disk should be storage, or the maker of your hard disk should be also be considered. You will be considering the maker of your hard disk. You'll be considering the portability of your hard disk. You'll be considering the security infrastructures and within or design for your data protection. So those are the things you consider that what you call it now under your physical model. Now we are talking about 3 models now: the conceptual. Who can remind me? We talk about 3 models now: the conceptual, what again? The what? The internal and the physical. Now, we also talk about the external models. Now, all these models interact with one another, and in their level of interaction, they come across what we call data abstraction layer. Now, the interaction between these models that are involved in the database design, all these models come together to form what we call data abstraction layer, where all the phases of database design and implementation is that one another. From this diagram, you will see that the external models relates to the conceptual model. The conceptual model gives back to the internal model. The internal model has obviously to do with what you call with the database of the physical model itself. So as the level is, so we have what we call the level, the abstraction, degree of abstraction. In the first level, which is the external model, the degree of abstraction is very high, because if this is Ada, this is Manuel, this is Abdullah. What Emmanuel can see, don't want Ada to see it. So don't want Ada to see it. What Ada can see, don't want Abdullah to see. So definitely you'll be doing a very high level of abstraction, meaning that you'll be hiding so many information from the user. Let's imagine you are on Facebook, you are on Instagram, you are on Twitter, you are on TikTok. You can only see the information about, you can only see the post about those people that you subscribe to. Yes or no?
Yes, sir.
So what they have done there is they have done the high level of abstraction, meaning that they make sure that you don't see everybody's. They make sure that you don't see everybody's post. You only see those posts that have been subscribed to you or ascribed to you or assigned to you. So we have done a high level of abstraction. Now the concept, which is the conceptual model, the conceptual model now talk about how all this data you have come together. No, let's say we have A, B, C, and D to E to Z. They all are on Twitter. They all are on Instagram. How do Meta manage this data? Meta will now form a conceptual model where it knows the data is going to collect from Mr. A, collect from Mr. B, collect from Mr. D, down to Mr. Z. When the Meta is now designing, oh, this is how I'm going to collect this data from them. This is how they are going to interact. This is how I'm going to save my data. This is how I'm going to. This is how they are going to relate to one another. This is the constraints and these are the limitations. So automatically, what happened there is that Meta has come up with a conceptual model on how it's going to make sure everything works. Within how he's doing his conceptual modeling, he has also do what he call from the degree of data abstraction. He has removed some data information that he doesn't care about. Yes, he may care about your taste, your food, your interests, but he doesn't care about your color. Doesn't care about where you live. Doesn't even care about whether you are eating. Does TikTok ask you whether you are eating today? Hello, class. Does Twitter cares about whether you are visiting today?
No, sir.
Twitter does not care whether you are eating today. Twitter does not care whether the fuel in your place is now 700 naira per liter. It doesn't care. Twitter does not care whether you don't even have data. They will even tell you, okay, go and buy data. Go and buy data. As if say, since data is free. So in the conceptual modeling, they have ignore those kind of informations. Now let's go down. When that comes to internal model, oh sorry. When that comes to internal model, under internal models, they consider the operating system they'll be using. They consider this kind of data management system they'll be using. Maybe they'll be using Oracle. Maybe they'll be using MySQL server. Maybe they'll be using there's this called Microsoft Azure. Have you guys heard about Microsoft Azure? Hello,
Yes,
class.
sir. Yes, sir.
Good, beautiful. Have you heard about Power BI?
No, sir.
No. Oh, you can go about Power BI. There are so many software. Have you heard about that Google BigQuery?
No.
Hello, class. So that being said, anyway, you can go and do your research on your own. So on that level, at that level, we are looking at what's up this kind. At that level, we are looking at the softwares they'll be using to manage their data and manage their conceptual model. Now, after they are getting their software, they're not going to be managing the physical model. Under the physical model, they'll be considering the transport it will take for movement between within how they're going to manage their hardware. Maybe logistics involved. In managing the database, they'll be considering logistics involved. Considering the security of the database, they'll be considering even the price of fuel. Meaning that at this level, they hardly ignore any data. There is what you call a least level or degree of data abstraction. Meaning that they'll be considering, okay, if you're going to store our data, if you're going to create a data warehouse in California, San Francisco, oh, what is the cost of building a data warehouse within that area? What is the standard of living? The manager that will manage it, what is the cost of managing it? What capacity that is going to be saving? If you are going to be launching a satellite-based cloud service, what's the cost of managing that kind of system? Are you with me?
Yes, sir. We are with you, sir.
Are you with me?
Yes, sir. We are with you.
Are you with me?
Yes, sir. We are with you.
So, as I've said,
yes, sir.
good. As I've said, under the physical model, there's a low degree of abstraction, and you have to consider so many things that will affect the physical implementation of the database. Imagine, everybody at least I can believe that everybody here has a bank account. Yes or no? Yes or no? And
yes,
there's a database
I have, sir.
There's a database that manages your bank account details. Now, if one bank branch is destroyed, it will not affect your account details. Will it affect it? If there's a robbery at one branch of your bank, will it affect your account balance?
Not at all, sir.
Not at all. That shows that they have designed a physical model where your data cannot be affected anyhow. They have designed a system where your data is not saved. Your data is not saved within a branch. Yes, you may open your account in one branch of the bank. However, your details will be saved in another place, so that they will also consider how to keep that data safe. Whereas that is will be done within your fiscal modeling or fiscal model. So, ladies and gentlemen, should in case you finish your program and you said you want to create a data warehouse for your special information system in Nigeria, where you want to be collecting information about buildings within Nigeria, or I want to collect information about water system or water within Nigeria, what information about people within Nigeria, you cannot do without going through these stages in designing your database and implementing your database. Are we together? Are we together? Hello?
We are together, sir.
Good. Now, furthermore, let's go to schemas. Schemas.
Yay! Obey.
Schemas refers to an overall description of the database. You all know what the database is about now. Then, definitely, you know the steps involved in the database now. You know the stages. You know the models that we are concerned with. Now, when you are now to describe the database, a schema is one of those things that are being used to describe a database. There are different types of database, different types of schema rather. Mostly they are what you call an entity relationship diagram are being used or is being used in designing in representing a schema. There are type of schema, although we call them sub-schemas, because the database is a overall schema give us the what you call it, the overall description of database. Now, these schemas actually affect of schemas. When you have those multiple views, each viewer will have his own schema. That's why we usually call a multiple schema. We also have what we call conceptual schema or sub-schema, which we use for conceptual model. Then we have the physical schema, which we use for physical models. Now, before I go further, let me go back to this diagram. In this diagram, we talk about logical independency and physical independency. Now, what do we mean by logical and what do you mean by logical and data independency? Data independency refers to the immunity of the application to changes in definition and organization of data. When we say a data is independent, we find that a data can change without affecting the usefulness of the function of the of data. If you are supposed to be a student and you change your color from black to red, does it affect your function of a student? Class?
No, sir. No, sir.
I can't hear you.
Not at all, sir.
Good. That's what we call data independency. That is to say, the immunity of user application to change in definition of organization of data. Because look at it again from another point of view. So many things happen on Twitter. People change their location, change your date of birth, change everything, but it doesn't affect the functionality of their profile. Yes or no?
Change location as in, sir. We didn't get that.
As in on your TikTok account, you can change your profile information now. You can try to change your name, change your location,
Yes, obviously,
change
sir.
so many things, but it will not affect your profile, your profile itself. So the functionality of the profile will not affect it. Yes or no? So
Yes,
that's what
sir.
we mean
Yes, sir.
by
It
that's
won't.
what we mean by data independency. There are two types of data independency in database design. You have the logical data independency and the physical data independency. For the logical data independency, we are referring to the ability to change logical schemas or conceptual designs without changing the external schema or user view. You know, if you come out to this place, under logical dependency, we can change this logical or we can change this conceptual model without changing the way the user view the user view the data or database. You can change so many things within this within this uh within this conceptual model without it affecting the functionality of the entire database. That's what we mean by logical data independency. Now, a logical schema is a conceptual design of database on paper. Now, that's what we mean by logical schema anyway. Now, of changing example of logical data independency is involve changing the structure of a database without affecting the function of the application. They're not affecting the way the application has been functioning all this while. That's what they mean by logical data independency. Now, the other part is the physical data independency that refers to the immunity of the internal models to changes in the physical model. Remember, you have bank account. If the bank decide to move your database from another location to another location, it will not affect the data balance. It will not affect the way your account has been functioning all this while. That is what they mean by that physical data independency. Mean that the change in your maybe they are using thank God that you are a generation that witnessed the change from 3G to 4G and 4G to 5G. Yes or no? Internet connectivity, you know of 3G, Abi?
Yes, sir.
I know of 4G, Abi?
Yes, sir.
I know of 5G, Abi?
Yes, sir.
Yes, sir.
There was a time MTN did the MTN, even all the telecommunication companies require that you go and change your SIM from a 3G to 4G SIM. Yes or no?
Yes, sir.
Does it
Yes,
affect
sir.
your phone number?
At all, sir.
No, sir.
No. That's what I mean by a physical data independency. Meaning that the change of your SIM card does not affect the operation of your SIM, of your phone number, of your data in operation of your SIM itself. That's because what we call physical data dependency. That your data is your data your internet your data is independent to changes in your physical model. That to say that changes in your internal model does not, or your internal model does not affect changes in your physical model. So in this regard, they're telling us that the logical schema stay unchanged, even though changes are made to file organization or storages. That's what they mean by what? Physical data independency. So it deals with details of storage structure from user application. That's what we're talking about now. Now, key concepts when it comes to logical and data independency, you have to avail yourself to these terms. When you hear conceptual models, you should know what it means. When you hear it means logical structure of data database, that's the meaning of the conceptual models. If you hear conceptual schema, it's called a logical schema, a description of a conceptual model. When you hear entity relation diagram, it's just a data model that describes the database showing tables and relationship. That's all. When you hear database logical design, it defines a database in a data model of a specific data management system. That's the idea of a logical data design. When you hear physical database physical design, it defines the internal database called storage, structure, file organization, and indexing techniques. Now, before we close the class for today, we are stopping on classification of database systems. Database systems are classified based on so many parameters, one of which is the data model. You know, there are many types of data model. One of the data model is the relational data model. When a system is if you want to use a database management system that uses a relational data model, example of which is the Oracle, the MySQL, and the assets of it today. They use what we call relational data models. There's another one today which we call object-oriented database management systems. Object-oriented models. They are the ones that use Java, script, Python for data modeling. So those ones are what we call object-oriented database designs. They are the one where you will just be drag and drop on and the rest. So you can also classify a database management system based on the number of users. If we have, that's why we have multiple users and single users database management system. In such a case, if you have a database that is a multiple user, that means that so many people can edit. So many people can edit it, update it, and review it together. Imagine if you have your account details in a particular bank. If you said that you make any changes in your bank account or bank details, anybody in any bank can access it, yes or no? Yes or no? Hello, class.
Yes.
Sorry,
Yes,
we'll
sir.
be closing the class very soon. My apologies for dragging you too much.
No problem, sir.
So what we mean by multiple user is that if you are a multiple user, so many people can edit, update, and view a database. That's what we mean by multiple users. When it's a single user, only one person can actually edit and review and update database. But many people can actually view it. Example of source is your result. Your result portal. You can view your result, yes or no? Yes or no?
That's
Yes,
true, sir.
Yes, sir.
Another person, another administrator can also view your result. Some people can view your result as long as they have access to the portal. But only one person can actually update, edit, and delete your result, which is your course lecturer as assigned by the school. Such a system is just a database is called a single user database system. So that only one person can have access to edit, update, and delete records in the database. That's what I mean by a single user. Now, apart from classifying database system based on users, we also have them based on distribution. Based on distribution, we have centralized data system. In a centralized system, what we mean is that the physical implementation is one place. Means that imagine a bank locating all its database within Ikoyi or within BI or within Abuja there. If anything happen to that system in Abuja, all your account details over the country will be affected. Yes or no?
Yes, sir.
That is an example of a centralized system. Shows that if anything happen to that central system where they keep all your information, then the whole system come crashing. That is what we mean by a centralized system. So it happens in your school as well. All your information in your school is actually being centralized, so that everything is kept in one place. Now, if anything happens to that place, then everybody, no matter any country he is, his students' ship will be affected. His account or information will be affected. Yes or no?
Yes, sir.
Now,
Really?
another type of
Yes,
database
sir.
system is a distributed database system where, if you look at this diagram down here, we have a distributed system. Google use a distributed system. Microsoft use a distributed system so that if one part is affected, other parts will still be functioning without affecting, without any loss. Are you reading now? That's why we have what we call a distributed database system. So that if one part has been maimed or something happened to it, it will not affect other parts. Example of such. Example of such is the police state for the Nigerian police system. The Nigerian police system. If you go and blow up a, when a criminal offense has been registered in one police station, they have a record of it. Yes or no? Yes or no?
Yes.
They
They have
do,
a record
sir.
of it. This record will not be distributed to all other police stations. So that if tomorrow an ROB came and destroy this police station, if you go to another police station, they'll know that you are a criminal. Yes or no? So that kind of system is called a distributed database system, where they have distributed networks, so that nothing, if one fails, other one will come, will be working. Your Google account uses such a system. Your Microsoft uses such a system. So many of these people of this big tech use such a system because they know that there ain't no way is safe in the world. So they won't centralize your system so that nobody will be targeting that same system alone. Don't forget that everything has its own advantage. The centralized system has its own advantage, and the distributed system also have its own advantage. So none can be said to be illegitimate or illegal. Now, finally, we have the homogeneous distributed system and heterogeneous distributed system. Now, homogeneous distributed system refers to the fact that if though it's a distributed system, softwares that can access each database must be the same. Meaning that if you have a distributed database system, you must be using access to access it. You must be using Oracle to be able to access it. You must be using Java to be able to access it. That is a homogeneous kind of system. But for an heterogeneous kind of a distributed database system, we are saying that you can use any software to access such a system. Is that taken?
Yes, sir.
So on this note, I will ask if there are questions. If there are no questions, just answer a small quiz or a small assignment. Class, any question?
No questions, sir.
Okay.
No
So on
questions,
this
sir.
note, we will end the class for the week. Hello? On this note, we will end the class for the week. Now, your assignment. Write a 2-page long essay on database management systems. Again, write a 2-page long essay on database management systems. Again, write a 2-page long essay on database management systems because that's our concern here. Our concern is not to be an accountant. An accountant will be using normal known Access, Microsoft, basically any accounting software that can do database management systems. Our own database is actually the Joe database management systems that are actually designed to accommodate your special data. So, can you write 2-page long essay on Joe database management system? So, thank you for your class.
Sir,
And-
yes, sir.
Yes.
Earlier today, you said you made mention of some assignments. You said we are yet to some assignments or an assignment to give to us. Is it the ones that we sent to the group that I said we should submit before 2 or before?
That one is quiz. That one is quiz. That one is actually quiz. It's meant from the main. Remember the main assignment. Ask your class self. That should answer that one. It's meant from the main.
Okay, so that
from
means
the
plus
main,
that
yeah.
means making 2 assignments you are giving us now.
Yes. So by next week, Monday, I'll be expecting the submission.
Next week, Monday.
Yes. Your online class, I said I want to see your final page on that online class. I said you guys should register for. Finally, thank you everybody. Enjoy your day.